So I've opened up Multisim, and what I'm going to do is build PLDs. So I'm going to click on New, or File New, PLD Design, Create, and I'm going to say Create an empty PLD. Next, I can name this whatever I want. So I can name it half adder or whatever I'd like to. And you can put a part number if you'd like, and then click Finish, and it will open up this new window. If I want to set some pins for inputs, I would click this button and copy and paste to get as many as I want. So if I was doing a half adder, I wouldn't need this many, but that's how you would do it quickly. I can double click this and rename this A, rename this B, get output connectors. So I'll have a sum, copy, paste, and a carry. Double click it to save the name. Then you can build it. So we're going to use place logic gate right here. And I'm going to use an XOR, and I'm going to use a 2-input AND gate. So I'm going to carry out if my two inputs are both 1s, and I'm going to output my XOR to the sum, my A here, my B here. I'm going to get my A there and my B there. So this is our half adder, and what I can do is I can actually test this pretty easily. If I click here, place digital source, I'm going to select from this window sources, and then it's going to show, oops, let me go back to these. Digital sources, I'm going to pick digital interactive constant. And what this will do is allow me to put inputs here. If I double click this, I can change which key on my keyboard will activate that button. So now if I hit the A button on my keyboard, it changes this from 0 to 1 or 1 to 0. Similarly, I'm going to change this one to B, and I'm going to wire these to my A and B inputs just so I can simulate and test. Then I'm going to use a probe, and I like using the blue probes because they are bright and visible. And again, that's just in indicators, probe digi blue, and this will show me when my outputs are 1s or 0s. So I'm going to click the run button, and right now I've got 0 and 1 on my output. I've got a sum of 1 and a carry out of 0. That's correct. If I have 0, 0 on my inputs, then I have 0, 0 on my outputs. If my A is a 1, I again have a 1 on sum and no carry. But if both A and B are 1, I have a 0 on my sum output and a 1 on my carry. So I can tell you that this effectively is a single bit adder, half adder. So what I want to do is save this, and I've already made a bunch of these, so I'm going to call this half adder 2, maybe even 3, depending on how many I've done. And then if I want to use this and see the entity of this, I'm going to click a new PLD design, empty PLD, programmable logic device 1, whatever, it doesn't really matter what the name is. Click Finish. And that opens a new sheet. So here's my half adder where I can see the guts of it. Here's my new programmable device. If I want to load in that half adder, I'm going to click right here, hierarchical block from file, and it's going to ask me which one of these would I like to choose. And here's the half adder that I just built, so I'm going to drop it in there. I can zoom in. It's called PLD1 half adder 2. It's got a sum output, an A, a B, and a carry output. So if I wanted to test again, I can use digital interactive constants to give me my outputs, my inputs, and then I can click to get my blue probes going here. I can wire these up. And in this particular case, I'm not going to change the key binding to these. I'm just going to click them with my mouse. So I can again see if A is a 1. Oh, it froze. It should not. There we go. So if A is a 0, B is a 0, outputs are both 0. If A is a 1, something's buggy. This should be lit. This is not connected correctly somewhere in here. So let's see if it's connected correctly there. Yep. It sure is. So, okay. Well, I'm having a bit of a bug right now. I'm not sure exactly why. Let's try running this simulation again. And once it finally lets me run the simulation, that one's not working. But I've done it with other blocks here. So here's another half adder that I've built, and I had tested this one in the past and actually built it into a full 4-bit adder, building full adders out of this. So I know it's working. If it doesn't work for this particular demonstration, then something's buggy with my program right now. As soon as it lets me simulate, I should be able to give inputs and outputs. Okay. Yeah, so there we go. So there's my carry, or my sum. There's my sum, and if they're both 1, there's my carry. So if I zoom in on this, I can open it. I can open the subsheet if I double click it, and that will open up what that schematic looks like. And that's the exact schematic that I have. I think the issue with this half adder is the fact that I put these probes and digital constants in there. Usually you don't do that. Usually you just write your circuit and then you build a top schematic like this one where I instantiate the half adder and put inputs and outputs to simulate. So if I wanted to build a full adder, I could do it in a couple of different ways. One is to take 2 half adders and kind of string them together and then use an OR for the carry out. Or you could build it just based off a truth table and use 3 AND gates and a 3-input XOR. So there's multiple ways of going about doing that. But you can actually build up an entire ALU here. You can use these other functions here. You can place a multiplexer. So there's a 2-to-1 multiplexer here, 4-to-1 multiplexer. Now note that these do have enable pins and some additional things in here. So you might want to look into how those work for Multisim. You've got encoders, decoders. You can even put an adder in here. It's got a half adder and a full adder. It's got a 4-bit adder there. Multiplexers, demultiplexers. We've got latches, flip-flops, counter, shift registers, and generators, which we haven't gone over. Shift registers, counters, and generators. So, and there's buffers. Buffers are basically like an inverter on the end of an inverter. All it does is just amplify the signal, basically, and separate the signal. And then you can use, of course, the logic gates by themselves. So, but you can continually, as long as you don't put the probes and everything in there. If I wanted to make a larger thing, I would use full adders. So here's a full adder, maybe not. So here's a full adder. If I wanted to make a 4-bit full adder, then I'll just do a 2-bit full adder for now. Carry out of the first bit goes into the carry in. Okay. This is my sum 1. This is my sum 0. This is my carry out. This is my A0, my B0, and my carry in, my A1, my B1. And to reflect that, I'm going to put these here. A0, B0, A1, B1, and now my outputs, sum 0, sum 1, and finally C out. So now I can save this as, well, I've got a 2-bit adder up there, 2-bit adder 2. So if I want to then use this in a larger top schematic or to test it out, I simply make a new PLD design, create. I'm going to use an empty PLD, finish, and I'm going to again use a hierarchical block, and I'm going to use our new 2-bit adder that I just built, and I'm saying, okay, I'll merge these nets, that's fine with me. Then you can set your inputs individually, just as we have in the past, using digital constants, and use the probes to see our outputs. So that's how you build PLD devices and larger things within Multisim and simulate them.